Alright, how do we do that? Well, you can't see it directly. Write down all your possibilities. Out of 10 trials, you get zero positive occurrences, 1, 2, 3, 4 through 10 positive occurrences. We want 2, 3, or 4. Alright, something greater than or equal to 2, but less than or equal to 4. Alright, how do we do that? Well, we don't do a complement here, but it's sort of quasi-complement if you like. We can take from the tables 0 through 4. Since we want 2, 3, and 4, we subtract out 0 and 1. Alright, so we start with the circle, and that's x less than or equal to 4. Get too much. Out of 10, p of 0.1. And then we're going to subtract from that, alright, 0 and 1, which will be listed as x less than or equal to 1. N of 10, p of 0.1. Okay? And then we'd go to the tables and find that. So n of 10, p of 0.1. And first we get too much. Alright, 0 through 4 is 0.998. And from that we're going to subtract out, 0 through 1, 736. So that's forgot my numbers, 998 minus 0.736 is 262. Alright, I want you to try the following. Let's try between inclusively 7 and 11 out of 15. Probability of success in only one trial is 0.2. Okay, so I want you to pause the video and try that problem. Okay, and then when you're done, you would do the answer as follows. Alright, so we have, this gets tedious after a while, so you should be able to visualize it instead of writing this all down. So those are our possible outcomes. We want 7 through 11. Okay, so what we're going to do is get too much, 0 through 11, then we're going to subtract out 0 through 6. Okay, so first we get too much. Right, instead of going 7 through 11, we get 0 through 11, which is just x less than 11, and a 15, p of 0.2, and that, since that's too much, we have to subtract something out of that. And what do we subtract out? 0 through 6. So that's listed as x less than or equal to 6 out of 15, p of 0.2. Okay, let's see if we can remember that. So we go to the n of 15 table, p of 0.2, then we're going to go 11, subtract out 6. Oops, wrong screen. Alright, so p of 0.2, too much, 0 through 11 is 1. Alright, and then we're going to subtract out 0 through 6, 982. Make sure I've got those values right. Alright, and there we have them. And that's 0.018 is the answer. Alright, what if I had arrange like this, no equal signs? Alright, x greater than 3 less than 7 out of n of 9, oops, sorry, p of 0.4. Okay, first thing, let's change that into, well, it's not necessary. We could change that to a statement using equal signs, but let's just look at our situation. Alright, greater than 3, less than 7, so we want 4, 5, and 6. Okay, that's all. So we go first 0 through 6. Sorry, I drew that circle a little bit big. We don't want 7. And then we're going to subtract out 1, 2, and 3. 0, 1, 2, and 3. So we go x less or equal to 6, n of 9, p of 0.4, and we can subtract out of that x less or equal to 3, which means 0 through 3, n of 9, p of 0.4. Okay, n is 9. Sorry, I'm having trouble finding the table there. P of 0.4, we want first 0 through 6, too much. Alright. 975, and then we can subtract out 0 through 3. Alright, 975, let's write that down. And subtract out 0 through 3, and 0 through 3 is 483. And the answer to that is 0.492. Alright, hopefully at this point you've seen enough tricks that you can do those types of problems yourself. Okay. Now let's look at a word problem involving the binomial distribution. It goes as follows. The operator of a website that sells subscriptions believes that 10% of the website's subscribers are foreign, that is, the original currency is other than US dollars. What is the probability that of the next 12 subscribers, if everything is going randomly, none of them are foreign, at least one is foreign, between 2 and 4 inclusive are foreign, between 2 and 4 exclusive are foreign, and more than 8 are not foreign? Okay, I think it's best if you pause the video and try that problem yourself. Okay, but I'm going to continue now and do the answer. Okay, so we have n of 12, right? 12 subscribers. The probability that any one is foreign is 10%. So we have, for at least the first few problems, p is 0.1, n is 12. And A asks us that none are foreign. So there's a probability that x is equal to 0, given that n is 12 and p is 0.1. By the way, x is equal to 12 is identical to x is equal to 0 is identical to x less or equal to 0 with the same parameters. Okay, so we can look that up directly from the tables. So let's find the table n of 12, p of 0.1, and less or equal to 0 or equal to 0 is 0.282. Alright, part B, at least one is foreign. At least one. So that means x greater than or equal to 1. N is 12, probability any one is foreign is 10%. Alright, so we, again, if you can't visualize, you write it down, 0, 1, 2, 3, blah 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 through 12. At least one means 1, 2 through 12. Okay, can't do that directly from the tables, but what we could do is 0 through 12, which is everything, and subtract out whatever's left. So we want that, we knock off the 0, and that's x less or equal to 0 with n of 12, p of 0.1. Well, we've got that in part A, right? And less or equal to 0 is 0.282. That's the complement of what we want, so the answer to this is 1 minus 0.282. There's 718, if I'm doing my numbers correctly. Okay, so that's that one. Let's look at question C. Between 2 and 4 inclusive are foreign. Trying to be precise here. Inclusive means including the limits of 2 and